Welcome to Java Performance webinar series from JPassion.com. Today's topic is Java I/O Performance. And not next week, we are going to have our last webinar on web performance on January 10th. So we will have a few weeks of break. Okay, so let's get started. Java I/O Performance. So we're going to look into 4 different aspects of I/O performance: reading and writing a file, reading and writing a text file, formatting, and serialization. Some of these issues is something you are already familiar with. So basic rules for speeding up I/O. So avoid accessing the disk. Accessing a disk is very expensive operation. And avoid accessing the underlying operating system whenever possible, and avoid method calls, and avoid processing bytes and characters individually. So these are the basic rules for speeding up Java I/O. So let's talk about reading and writing a file. So you could actually read and writing a file using several different schemes. First, you might use file input stream directly, or you could use a buffered stream, or you could do your own application level buffering. So let's take a look at each of this in a bit more detail. If you are using file input stream directly, then you are making a lot of calls to the underlying runtime system using read method of file input stream. And basically it's reading a byte of the file one at a time, which is not really efficient. So recommendation is using a buffered input stream. So you get the file input stream and then you're going to buffer it. So that system will actually buffer the data so that it could handle the next request from the application. So this is probably the right approach for most applications. Third approach is that you create your own buffering yourself. So in this case, you find out the size here. You actually provide the 2K buffers, and then you're reading that 2K from the file. All right, so let's try our first exercise. So we're going to actually try 4 different aspects. So we're going to actually read and write a file, and then reading large buffer, and then direct buffering. So this is the approach 2. So let's actually take a look at the code first, and then we'll run this application. So approach 1 is using file input stream directly. So it's actually not recommended because it's reading 1 byte at a time. The approach 2 is using a buffered input stream. So we buffered the file input stream object. Okay. And approach 3 is you create your own buffer yourself, and then you're reading that chunk of the data. And the last one is you actually read the whole thing in a single shot. Okay. So you find out the size of the file, and then you allocate that size of the file, and then you just read. Okay. So let's run this application. These are all Maven projects, so you should be able to run the application using any IDE of your choice. I'm using Eclipse IDE at the moment. Okay, so you can see read method. So using file input stream is taking 15 and 13 milliseconds. Usage of buffer. The buffer stream takes only 39 milliseconds. And you have better performance if you do directly buffering. So it's taking 13 milliseconds, and reading the whole file takes about 8 milliseconds. Okay. But in general, you want to, because you don't know the size of the file sometimes in advance, it's better to actually use this buffered input stream in most applications. All right, so let's move on to the next. Reading and writing a text file. So there are 2 different approaches. One is using data input stream and read line. This is actually deprecated, so you probably don't use it anyway. And also using buffered reader and file reader. So this one is obsolete, and it doesn't actually convert the bytes to characters. So if you think about it, basically the file could actually contain the characters rather than just bytes, and the characters based on the international characters. Okay. So in this case, even if you're using the buffer stream, and then if you're using data input stream, and then here again, this is actually reading very inefficiently because it's not really converting the bytes into characters. So the better scheme is using buffered reader and the file reader. So you get the file reader, and then you read the buffered reader, then it's going to actually understand the characters. All right, so let's try read and write text file. So, usage of data input stream takes about 152 milliseconds, and the buffered reader and file reader takes only 47 seconds. Here, basically, we are actually, reading even ASCII files, so it doesn't even contain some, Asian characters and things like that. So, performance difference could be actually even significant if you're dealing with a file that contains the international characters. Okay. All right, so this is the case that is using data input stream, and this is the case that you're using buffered reader and file reader. Okay, and then it calls a read line. All right, and in terms of the file, so it's basically it's just reading changelog text file, which is actually ASCII file. So as I said, I mean I could actually have a file that contains international characters, and the performance difference could be even bigger. Okay, moving forward. Formatting. So 3 different ways that you can do string formatting. It could be fixed string, or it could be simple formatting using plus, or you could use message format class. So fixed string is basically you create the string literal, and or you could create a string using plus sign. Again, string concatenation is expensive than string literal, as we learned before. So when you have a need to manipulate, it's better to use string buffer or string builder class. Message format is you can parameterize some value, so you can have a message format object, and you have these parameters. Okay, and then you create an object, and the object array, you actually assign the values, and so then you can call the format method passing the array, replacing the values of these parameters. And this is very expensive operation, so it provides a flexibility for replacing certain values, but it's expensive from performance standpoint. So you want to minimize this parameterization as much as possible, or if possible, not using message format if the performance is important. All right, so let's try exercise 3, formatting. Okay, so here fixed string takes about 1 millisecond, and simple formatting using plus take 41 milliseconds, and message format takes about 376 milliseconds. So obviously message format has a huge performance hit. Okay, the last topic. Yeah, today is going to be rather short presentation. So last topic is serialization. So serialization of a complete object tree can be very expensive from performance standpoint. So you want to make sure you're not really serializing fields that are not needed to be serialized. And these fields include, for example, fields that are not important, meaning it doesn't really, they don't play any role in the business logic. Or if the value of the field can be reconstructed the later on after it's actually deserialized, or some of the fields, for example, some of the fields contain values that should not be serialized in the first place. For example, like a thread object or a file object, because they get changed anyway once they get deserialized. So make sure you're not really serializing a certain set of fields that meet this criteria. All right, so let's do serialization exercise. So here basically we are comparing the case where every field of an object gets serialized, and then we are selectively serializing. So obviously, the time difference is very significant. Okay, so if you take a look at the code, so this is the test object, and this is the test trends object, and basically we are actually serializing. And if you take a look at test object, we have 4 fields, and one is int, primitive type, and string, and date, and JPanel. Okay, JPanel could be pretty expensive. Okay, so transient, a test object transient is exactly the same code, but this time we are actually making string as a transient and JPanel object as a transient. So we are not serializing these 2 fields. Okay, and the result is again very significant, almost more than 10 times faster. Okay, so that is pretty much what I have. Again, today's relatively short presentation, so let me